What's going on, everybody? Johnny Bannon here at Trepa Technologies, and in this video we're going to go over IP DHCP snooping in our CCNA free course. If you like this course and this material, please be sure to like, subscribe, and share with everybody you know, and check out that description below if you'd like to be part of our live virtual training or our self-paced course with over 1,000 practice questions and access to our team. Now with that sales pitch out of the way, let's go ahead and get started with Layer 2 security, and in this specific video, we'll be covering DHCP snooping operations, why we need it, and also configurations. We will have a lab with this section. So let's go ahead and get started. I'm going to minimize my face, and let's get into the lesson. Okay, so as I minimize my face here, let's go ahead and talk about this section, Layer 2 security. So in the CCNA, we're going to be covering all things Layer 2 security. Not all things, right, but DHCP snooping, dynamic ARP inspection, port security, and then also network access control, going over AAA protocols. For some of you that may be more experienced in network engineering, but are just getting your CCNA for maybe a requirement, or you just want to finally get certified, you know that there's other things we can do like VLAN access lists, private VLANs, BPDU guard implementations. However, in the CCNA exam, if we come over here to our objectives or our agenda, it's just going to be DHCP snooping, dynamic ARP inspection, and port security that we're going to cover in this lesson. And then we're going to cover AAA as well. So this is the Layer 2 security fundamentals or technologies that we're going to cover for the CCNA exam. However, in our Academy course, you will get some extra bonus videos going over things like private VLANs and VLAN access control lists, and other things you can do at Layer 2 to secure that Layer 2 infrastructure. Now, quick overview. So securing our Layer 2 infrastructure is a very important component when designing, configuring LANs, and especially the campus network. So we got to get in the mindset as a network engineer that it's also our role to secure what is our equipment. So that being said, we want to make sure that when we design campus networks or design a LAN, we want to make sure we have our Layer 2 in mind. We want to work our way up that OSI model. With Layer 0, of course, being the user, which it'll be part of our job to educate the user. Layer 1, making sure that we do have some Layer 1 security if we need it. I like to think of that as maybe we use fiber instead of copper, and also just the physical environment. And then Layer 2, this is where we make sure that our switches are not vulnerable to common Layer 2 attacks, which we're going to talk about. And that's when malicious threat actors manipulate things like DHCP, spanning tree protocol, the MAC address table, also ARP if we're in an IPv4 environment. Just very basic things. Again, making sure we don't have open ports where someone can come plug in their Kali Linux Raspberry Pi into our wall jack and then boom, they cause a broadcast storm. So we want to make sure we have good port security. We also want to ensure that we have good network access control. Now this can be a lot, and it is a lot more in depth than what we're going to cover in the CCNA. Meaning, we're not going to deploy an identity services engine. We're not going to deploy TACX and Radius and put certificates on clients and just all the role-based and rule-based access control that we can have with network access control using a Radius or TACX server. No, what we'll cover is just the basic authentication, authorization, and accounting, and probably just a basic open source TACX server that'll allow us to create username and passwords. We're not going to integrate ADUC into this, but just for your knowledge, NAC or Network Access Control can be very robust, especially with today's technology, Cisco DNA Center, Identity Service Engine, and especially with that single pane of glass controller-based networking. That's a big thing. But in the CCNA, we're just going to cover the basics. Okay, so some more security overview. So to ensure we take a defense in depth approach, we must implement logical controls on our network devices. This is going to be the key role that we play as network professionals and network engineers. There's many technologies that we can implement. Again, I've already kind of went over this, but there's a quick list for you all. So again, we have DHCP snooping, dynamic ARP inspection, which gets built off the DHCP snooping binding table, which we'll go over. We have things like private VLANs, storm control, BPDU guard, and STP security. We have VACLs, which are VLAN access lists, and then again, port security. And a lot of times, if you talk to if you talk to the SOC, right, the Security Operations Center, they think port security. They may be thinking actual port numbers and protocols like ACLs and firewalls. We're talking about the actual physical port that you can plug into in the switch. And then of course NAC, which is going to be based off our AAA protocols, doing .1x, radius, and TACX security for getting access to our network, to our networking resources. Okay, so now to start this off, let's cover DHCP snooping. So DHCP snooping protects our LAN architectures by providing protections against DHCP-based attacks. So if you're following this course in order, we went over DHCP in section 6, we went over our services. So DHCP is how we dynamically assign IPv4 addresses. This takes a DHCP server and then also clients to actually request from the DHCP server. So in that transfer, right, of that DHCP IP4 address assignment, we do something called DORA, which is the actual DHCP process: discover, offer, request, and acknowledge. Well, of course, with these protocols, when we built them, we did not have security in mind. There was no way to authenticate that we're actually receiving information from a legitimate DHCP server. So because of that, there's a couple different attacks that we leave our LAN vulnerable to if we have just DHCP running with no protections, like a DHCP starvation attack or having a rogue DHCP server doing man-in-the-middle attacks. So the goal of DHCP snooping, when activated and enabled on our switches, is to authenticate which interfaces should accept those DHCP messages. And along with that, we're going to go over some different DHCP messages like NAC, which is not acknowledge a server message, and decline, another client server message. But we're going to essentially say, hey, which interfaces on this switch should be accepting these DHCP messages. So DHCP snooping will filter only DHCP messages, that's it, and it uses something called trusted and untrusted ports to either allow or deny/drop DHCP messages. So now let's get into a little bit of how we architecture this out. So by default, let's say when we enable DHCP snooping, so we type in IP DHCP snooping on our switches, and yes, I have bad spelling and handwriting. By default, all ports on that switch are going to be untrusted. Now, what we mean by that is untrusted ports can only accept DHCP client messages, okay? So they can only accept the discover and the request message. And then, of course, we have a deny message that we'll get into later, or a decline client message. So the untrusted ports should only be accepting DHCP messages from clients that are doing discover and request. Now, trusted ports, they actually accept all DHCP messages, but I just put in there that they will allow DHCP offer and DHCP act, but they actually allow everything, okay? Trusted ports allow all DHCP messages. Now, if an untrusted port gets an offer or acknowledge DHCP message, it's going to drop that. So in our next message, we'll show you what that looks like. So if we look at this architecture here, right? We enable IP DHCP snooping on both these switches. This threat actor here wants to be a rogue DHCP server. So let's say this computer A is going to send out a discover message. That discover message is broadcast. So that's the D in our door request. That's where our client broadcasts out saying, hey, in its DHCP header, it's saying, hey, I need an IP address. It does something called a client hardware address, where in that DHCP message, it says what its MAC address is, right? We'll get into that. That broadcast, though, since we're on a LAN, and let's say we're all part of VLAN 10 here, or let's say we don't have VLAN, so we're all part of the same broadcast domain, every single port is going to flood that broadcast out in the active port. So on our active ports, we have computer B here, which is just going to receive it and do nothing. And then we have this rogue DHCP server. And then we have our legitimate DHCP server up here. So by default, this rogue DHCP server is going to try to be a server, and it's going to send back a what? A DHCP offer message. When this port here that's untrusted by default, receives that offer message, well, what's it going to do? It's going to drop it, because remember, it only accepts DHCP client messages. So that's a way we can protect ourselves from these rogue DHCP servers and the DHCP layer 2 based attacks. Now down here in this bullet point, it says typically uplink ports are trusted and downlink ports are untrusted. So what do we mean by that? Essentially, when the legitimate DHCP server responds inbound on this port, is going to be our DHCP server messages. And then outbound, right? It's not going to matter because even though this is untrusted, it's outbound, okay? So it's not actually receiving that DHCP message, it's just sending it out. But then again, switch 2 here, this port is going to receive it, and since it's trusted, it will allow again those DHCP server messages, okay? And then again, on this untrusted port, it's sending, not receiving, so it's also going to allow that. So that's another key thing here. A lot of times when students get confused, they're like, well, if untrusted only accepts client messages, then what's going on here? Again, that's because it's outbound, right? We're not receiving it when it's coming downstream from our DHCP server here, which is going to be, in this scenario, an iOS device, a Cisco router. So got a little bit ahead of my slides here, but here we go. So if an untrusted port receives, keyword here, receives a DHCP server message, it will shut down and go into an error disable mode. Essentially, that's our protection, right? That port is going to be shut down, no longer receiving. And then trusted ports can receive DHCP server messages and forward them downstream to the client. So again, with that trusted port on the receiving end of DHCP server messages, it's going to allow them, and then it's going to send it outbound, okay? So those untrusted ports only care about the DHCP messages it's receiving, okay? Now, let's go over the different DHCP attacks and why we need DHCP snooping. So one attack DHCP snooping can prevent is a DHCP starvation attack. Essentially what this is, we have a malicious threat actor that's generating a bunch of different DHCP discover messages with different client hardware addresses and sending them to the DHCP server and exhausting its DHCP pool, okay? So that no other legitimate clients will be able to receive an IP address. Now you may be wondering, well, how does DHCP snooping protect this if an untrusted port allows that, right? If this is untrusted, which is how it's supposed to be for clients are supposed to be on untrusted ports, what's stopping it? Well, part of that DHCP snooping inspection, when it inspects DHCP messages inbound, it's also going to check something called the snooping binding table, the DHCP snooping binding table. And what that's going to say is that, hey, this client's source, let me rewrite that here. This client's source MAC address is tied to this interface and tied to an IP address that's already assigned to it. So now what we're saying is, hey, this discover message is invalid because we already know that this source MAC address has a IP address already. Now you may be wondering, well, isn't it too easy just to spoof this source MAC address? Yes. However, one thing that DHCP snooping looks at is actually something called the CH adder. The CH adder is what I call it for shorthand. That's the client hardware address, and that's actually in the DHCP header packet. So it's going to verify that DHCP header, okay, along with the source MAC address and along with the DHCP snooping binding table to prevent this starvation attack. Something else we can configure that we're going to get into, something called rate limiting, where we can actually limit the amount of DHCP messages on an interface, which can also help prevent that starvation attack if we have a sophisticated attacker that's changing its source and its client hardware address, okay? So a bunch of different ways we can prevent that. So in the again, going over this starvation attack a little bit deeper, in the DHCP discover message sent by the malicious actor, the client hardware address field in the DHCP packet will be changed for each DHCP discover message. So the client header address field is what's used by the DHCP server to see what source MAC addresses have been assigned IP addresses, not the actual client source MAC address. So what we're saying in here is that essentially this, if they're changing this, the DHCP server just looks at that. And that's why we need that binding table, right, that we just discussed in the last one, that will correlate source MAC address to the client hardware address, and of course the IP address is assigned to them, okay? So by default, the DHCP server only looks at this, not the actual source MAC address, but the binding table is going to look at both, and that happens when we enable DHCP snooping. Another type of DHCP attack is going to be the poisoning attack. So a DHCP poisoning attack is a man-in-the-middle attack where a rogue DHCP server will intercept DHCP requests from clients. That rogue server will then respond to the client's DHCP discover and become that client's default gateway. What this enables is the rogue DHCP server to get all traffic sent to it, do some inspection on it, and then forward it out to the legitimate default gateway so that user can reach the external resources trying to access, like the internet, like maybe Google. So the user will have no idea that all of its traffic being inspected, but that DHCP server, that rogue server, now has all your information. Again, with DHCP snooping, we can prevent this because any client that's connected to this switch should be on a what? An untrusted port. And that untrusted port will not allow any server messages like that DHCP offer message. So how does a client, right? So the DHCP process, even though we have a rogue DHCP server, wouldn't it still be getting an offer from the legitimate DHCP server? Yes, but we have no way to actually know which one the client is going to accept first. So what could potentially happen is that if that rogue DHCP server offers that computer an IP address first, when the legitimate DHCP server's offer actually reaches, the client's going to send back what's called a decline message. Another DHCP client message called a decline message saying, hey, I actually don't need your offer. I already got one, okay? So there is no built-in protections against a DHCP poisoning attack unless we do that DHCP snooping and enable it on all of our switches. Okay, now let's go over the different DHCP messages. This is going to be important information for when we actually go over DHCP snooping and get into the configuration. So DHCP snooping at its core, it differentiates between DHCP server and client messages when filtering DHCP messages. So remember, again, untrusted only allows client. Trusted allows all messages. So the type of DHCP client messages we have are discover and request, which is again part of our DORA process like we already talked about. And then we have DHCP decline, which means we're going to decline IP addressing information from a DHCP server. Then we also have the release, which is used to tell the DHCP server it no longer needs its IP address. You see this on Windows when we do an IP config release. That's us telling the DHCP server and broadcasting out, hey, we don't need this IP address anymore. And then maybe we renew and get a new one, right? And then we have DHCP server messages. So we have the offer and acknowledgement, which is again a part of our DORA process. And then we also have something called the NAC, a new message type, which is used to actually decline a client's request. So kind of the inverse of this client message, where the server can decline that client's request. And this could be when we have excluded pools, right? So if we have an excluded pool, and maybe if for some reason a client is asking for an IP address within that pool, we can decline that. All right, so let's go over the DHCP snooping operation one more time. So when a trusted, and this is going to be in a little bit of an order, okay? So when a trusted port receives any DHCP message types, it will forward the message as normal. So again, with that trusted port, all is good. All DHCP messages are good. Now, when an untrusted port receives any DHCP message type, it's going to inspect the DHCP packet, the actual DHCP header and packet. And then it's going to perform the following actions. So at a base level, if the DHCP message is a server message, it's going to discard that packet. So on untrusted ports, server messages are no-go. If the DHCP message is a client message, it's going to do the following checks. So if it's a discover or request message, it's going to check that frame source MAC and the DHCP packet's client hardware address field. If they both match, that's going to forward the message. If they differ, like we're trying to do that DHCP starvation attack where the source MAC address doesn't match the client hardware address, and we're trying to starve the DHCP server with its IP addresses, guess what? It's going to discard that message. Now, again, guys, remember that we know advanced or a sophisticated user can change its source MAC to match the client hardware address, okay? Now, with release/decline messages, this is going to check that the packet source IP and receiving interfaces match the DHCP snooping binding table entry. And if they match, they're going to forward. If they don't match, they're going to discard. So this is when we're sending those DHCP release and decline messages. We're going to check the packet's source IP and the receiving interface matches the DHCP snooping binding table entry, okay? So that's how DHCP snooping works. So now let's go over configuration. So to actually configure it is pretty simple, and I'm actually just going to zoom out of this real quick so we can get the full. So to configure DHCP snooping, the first thing we do globally is just type in IP DHCP snooping. So here, if we're going off this diagram, we do that on switch 1 and switch 2. And then, since we have multiple broadcast domains with the use of VLANs, we have to enable DHCP snooping on a per VLAN basis. And yes, you first have to enable it globally and then enable it on each VLAN. And then we have something that's optional here. Something optional called the option 82 field. This is going to be a DHCP option, just like the options we showed you in our previous DHCP video, like option 150, which does a TFTP request to a call manager from VoIP phones. The different options like 66 and 67, which do Windows deployment services, pre-execution environments, right, to image over the LAN. The option 82 field, what that does is when you enable DHCP snooping, it automatically adds it when a client comes inbound here and then sends that DHCP message outbound here. It's going to add that 82 option onto the DHCP header. Now, what that does is it relates the MAC address of that client to the actual DHCP packet all the way through. Now, why would they do this? Because sometimes we have something called relay agents, and in those relay agents that are not part of the LAN, this MAC address may be stripped. So what happens when we enable DHCP snooping is our trusted ports, by default, actually will decline or drop messages with that 82 option. So what ends up happening is if we have a diagram like this, where the computer sends the DHCP offer, switch 2 is going to add that 82 header. When it sends it outbound here, it's going to get declined right there, okay? It's going to be declined by that untrusted port. So sometimes in our environments, like if we're using relay or if we have multiple switches, we want to disable that option 82 field. And we'll actually show you this when we get into the lab. And then next, we have to define our trusted interfaces. So this is again going to be the interfaces that are going to be receiving incoming DHCP server messages. So in this network diagram here, which ones would be our trusted ports? So that's going to be the ones that are receiving DHCP messages. So if we look right here, if this is our DHCP server, when it sends server messages this way, this interface and this interface will be receiving. So those are going to be our trusted ports. Something else that's optional that we can do here. Let's see, there we go. Something else that's optional that we can do here is we can also do a rate limiting. So we can rate limit how many DHCP messages can be received on a link per second. So obviously, where do you think we wouldn't want this to come into play? Maybe like right here, we don't want to rate limit to like 10 because every single computer that's looking for a DHCP message, well, they're going to be received on that interface. So we maybe don't want to do it there, but we can do it on the actual client addresses right here to help us protect from a DHCP starvation attack. So here's this example. Look at the actual binding table. So with this command done on the switches, so what we can do here, DHCP snooping binding, we can actually see the IP address bindings to the source MAC address. So pretty cool here. Now we're actually seeing how we can correlate the source MAC address with the actual IP address at the actual switch. So now our switches are doing some of that verification and checks for us before any malicious DHCP message can reach the server. Okay, so that's going to be it for this lesson going over DHCP snooping and layer 2 attacks. So stay tuned. We're going to do a lab, guys, and in that lab, we're just going to quickly configure DHCP snooping. We're going to do some Wireshark captures, do some checks, and then we're going to move on to dynamic ARP inspection, which actually also gets built off the DHCP snooping binding table. So I want to thank everyone for viewing. And if you're interested in some live virtual training or in-person courses for your unit or organization, please look in that description below and reach out. And if you're an active duty, National Guard or Reserve soldier, you can also use your Army Cool or the Army Ignited system for free training for $4 grand a year, just like tuition assistance. And guess what? Trepa Technologies is a vendor. So if you want to get our live virtual training or our self-paced training for free and you're a soldier, click that description below and see how you can apply on Army Ignited. Thank you, and don't forget to like and subscribe.